Lightings and PLC systems. This episode of My Ramblings. When I worked at Lantiv, I did some lighting design. You know, went through all the criteria and processes I had learned while I worked at PwC San Diego. And you need a minimum number of lumens, and to have a uniform lighting, I mean, sometimes you have a few extra fixtures and stuff, and um, so I had placed some fixtures according pretty much the same procedures that I use in some tutorials that I wrote. I wrote these after I left civil service, but basically it was because I was, finding project work here, and sometimes when you do lighting design, it really comes down to what did your engineering firm contract with the architectural firm to do, and amazingly enough, you know, you still have to be flexible there because individual architects within architectural firms will actually do things somewhat different. In other words, some want to select all the fixtures, which is fine. Some want to even select the light source, which is fine. I mean, for architectural aesthetics, and I realize it's far more complicated. But I don't know what approaches they do for everything, but they have to set an environment, and they have all kinds of intents that they want to establish that they can do with lighting and color selection and layout of the building and stuff. So it's more than just providing space and saying, but so when they want so when some of them select fixture, you roll with it because, well, that's, and I always wanted the architect to select a fixture anyway because, I don't know how to match the architect's aesthetics intent with the fixture, but sometimes they just want you to run the calculations. Sometimes they give you a layout. You kind of gauge the situation, what the contract says and stuff, and as to, well, should I even run lighting calculations on this? They've got thing also well laid out and also everything specified and what have you. Um, Sometimes they want you to select the fixtures. If the firm is getting compensated for that, there's no problem with that. So anyway, so I lay them out. And the feedback I get is that, well, I just had like 3 or 4 that were situated to provide more reflection near something to ensure that you didn't have a dark spot or something that was out of the luminance ratio range, or I don't want to call it that, uniformity for horizontal. Um, they're gonna think we don't know what the hell we're doing if you lay about that. It was just 3 or 4 that was kind of into an area I guess that had sort of enlarged, but calculations showed that would have given us what we needed for our quality lighting layout. And then so I finished this, and this new guy, I guess he was an 11 or something, he had come in from the outside. Acts all pomp and circumstance type. These are your lighting calculations, and I'm sitting there thinking, oh, God, man, this is like, this isn't even basic. This is like, this is like preliminary requisites before you start even getting into learning about lighting design. I had done some lighting design at PwC San Diego, and I was doing, I was kind of interested in it and its relation to electromagnetic theory. I mean, lighting is electromagnetic radiation. And this one of the senior engineers there, I guess, was aware of some of the lighting stuff I had done in assessing the lighting. Light travels in a straight line. He gave me a lighting design manual, and so I had undertook the process of going through understanding and kind of use that as the methodology for designing lighting. The the thing was sort of almost from the perspective of a contractor in a sense. It was Westinghouse. So I think I had begun to expand on that, because yeah, sometimes you have to account for um, a lot of actual lighting loss factors, but that's a long story, and you'll have to buy the tutorial. pdhonline.org. Go there. EE 710 at 711 are the prior ones. The first one was the zonal cavity method of lighting calculations, and I took a different approach than most of the lighting design resources you can find out there. Most of them start, with all this knowledge of stuff you have to know, and now, okay, now finally you can do this. I started with, here's this form that we need to do the calculations, and we're just going to assume somebody else on the design team provided those values for you. And then the tutorial step through where now, you're that guy, that team member, and now you're doing the analysis and what have you to provide those values. And I've got, I don't know, 10 tutorials I wrote. It's mostly, initially they were written so that whenever I had a lighting design, I didn't have to go try to remember everything. I had a guide, sort of my design guide for doing this work. And so at one point, one of the engineers there, he was kind of into PLCs and stuff. He wanted to do a PLC controlled lighting system. And so we had a lighting layout for, I think it was a maintenance facility. And what he wanted to do was to be able to individually control every light fixture, so that, and it's actually a pretty good idea. It's one way to only use the lights that you need. But he was under the impression that you control them more than one at a time. You can also set them up into zones. I mean, if you control them one at a time, you can also set them into zones. So if this guy wants to light up this bay, these fixtures come on. Trouble is now you have, if he wants this bay and then somebody lights the adjacent bay, now you have light fixtures that would overlap. But he kept, if I remember correctly, he was almost insisting that, no, I want one light fixture per bay. And no, that's kind of going back to the rambling on the Navy's paint facilities. If you only have one light, you only have light coming down at the top, and yeah, you get inner reflection, unless they're all just right at the top. You still, most of it's going to be a direct component. Some of it you will get some inner reflection, but they obviously weren't getting enough because they couldn't see well enough to paint the sides, and so they needed to go redesign the entire lighting system and start from there. Anything else is just, next thing you know, they're going to have 500 fixtures on the walls and stuff, and I'm not trying to poke fun. I'm really just saying, that's the right approach, is to start with your general illumination. Make sure that, you're getting that from that, what it can deliver, what you need. And then you provide task and spotlighting to supplement that. But to start where you have, the idea of just one fixture is going to, or just one, row of lighting fixtures pointing, with the photometrics to direct the light straight down. It's not going to give you what you need, no matter how nice the idea was for a PLC controlled system. And didn't end there. I'll get into that, but I just want to emphasize that lighting isn't there to save you energy. If you wanted to save energy, you just don't put any lighting system in. Of course, you can't use it if you have a roof or walls, but lighting is the purpose of lighting is to adequately light. And when I say adequately, I don't mean just by numerical numbers. As I point out in one of my tutorials, the 1983 Illuminating Engineering Society of North America was a transition, part of the transition phase from prior, where people just thought in terms mostly of numerical, calculations, how much or the quantity of light that I'm delivering. Um, but the 1983 IESNA handbook is is all about quality lighting. Um, so if you're following that, then you're not doing what even today people say. Well, people used to do, just quantity of light was all that was important. But really, they're referring to pre 1983 and perhaps after 1983. Well, you know, parts of the industry caught up, I guess. But so this guy goes into, and this has to do with the underlying things as well as anything else. And so he starts going through this step by step by step by step by step, and I have no idea what his rationalizations are, what his engineering analysis, for lack of a better term, is in getting from points from step A to step B, step B. And then he goes on to step 5 and he says, right, okay, I'm following along. I don't understand exactly what the hell you're talking. So, nope, you're wrong. You don't know what you're doing. What? You were trying to explain your step process to me. You didn't tell me that, what the hell you were doing to get to step A to step B. Besides, here I am. I'm in the mode of following along. You've taken out any thought processes because of the way that you're doing this. And if you wanted to know what I thought, you shouldn't you shouldn't have put my mind in a sleep mode. Maybe uh, I had no idea that he was testing me for that. Usually, I try to gauge people's knowledge and stuff, and I don't want to embarrass them or make them think that I'm superior. So I don't try to tell them, "Oh, well, I caught you." It's just the way he did it was, based on my school teaching education. he, he was ineffective at what he was trying to discover. But anyway, so um, and I think I felt that I couldn't trust the guy. I was trying to tell him, we do need to have more than one fixture and stuff, but he wouldn't hear of it. I don't know if it was just that he wanted it his way or the highway, or he didn't want to reveal that maybe he was going to have zones, or he didn't grasp the nature of the zone. But so we ended up not doing the project, and it was a shame because I would have really have liked that. Anyway, I think I did one PLC project when I was at PwC San Diego, but a lot of times they're not justified. Back then PLCs were expensive, and you know, uh, sometimes to do them you have to say, well, am I doing this just for me, or you know, and so I don't recall if I actually ended up doing it. I found a small micro PLC, um, and I don't remember, you know, the cost comparison between the parts and components. And then the one thing that you also have to account is that you have to have somebody that knows how to run the PLC thing. That's why you call for people to come out and teach the maintenance folks, the shops, how to run it and make sure they understand the troubleshooting and stuff. And I don't recall what I ended up doing, but I think I might have ended up just going with an electrical mechanical lighting control relay or switch or something, because it's not economically viable. It's just you have a PLC. Just to have a PLC is kind of pointless. Anyway, I'm going to leave that ramble at this. Some of this stuff I remember. Other stuff is, you stop it. You consider so many different alternatives and stuff. And going back 20 years, it's like, well, which one of those alternatives did I end up with? It's like, geez. Okay. See you next episode.